All right, students, I'm back here, part C, example 1. So looking at this one, again, thinking about my condition, right away I can see that I'm for sure my y cannot be equal to 0. Also from this one up above, since I'm dividing by this whole thing, this x cannot be 0 either, because that would mean that I would have 0 divided by 0, which is not allowed. So now I can do my inversion and simplify. So I've got 5x squared times y cubed times y cubed from flipping this over y to the 7th times 30 x y to the 4th. So up top, 5 goes into 30 6 times. X squared and x are going to cancel. That's going to leave me just an x on top. So x, this is going to leave behind an x. Here I have y to the 6th. Down here I've got y to the 11th. When I cancel those out, that's going to leave me y to the 5th. So in the end, my simplified expression, wrong tool, my simplified expression is going to be equal to, all I have left on top is x, and on the bottom 6y to the 5th, and x and y cannot equal 0. So I'm going to put a semicolon in there to really separate that out. Let's look at the next example. So in our next example, let me see if I can slide that up. All right, maybe I can manage to erase that thing. Okay, so again, looking at my conditions, straight away, x squared plus x cannot be 0. X cannot be 0, so I'm going to write that easiest one down. X squared plus x, that's x times x plus 1, cannot be 0. Therefore, x cannot be -1. And x can't be 0, but I already have that. Since I'm dividing by this whole thing, it cannot be 0, which means x plus 3 also cannot be 0. So x cannot be -3. All right, I'm going to flip this over. I'm also going to factor. So this one factors into x plus 3, x plus 2. When I flip it over, I've got x in the bottom. Again, we know this factors x times x plus 1. I flipped it over, so I also have x plus 3 on the bottom. Doing my simplification, x cancels with x plus 3 cancels with x plus 3, and I end up getting x plus 2 on top, x plus 1 on the bottom. Do not be fooled. You cannot cancel these x's. That's not true. So x plus 2, x plus 1, given x does not equal 0, -1, or -3. Last example. Let's move it up. Whoops. Again, the random erases. All right. So in this one, make it just a little bit bigger. Maybe. Or not. Well, all right, we'll go with it as it is. So I'm dividing by x plus 5 over here. So I see that x plus 5 cannot be 0. I'm also dividing by this whole thing. So if I factor that, that's x plus 5 times x plus 1 cannot be 0. So from those together, x cannot be -5. That's also this solution. And this one is -1. So this is like that over 1, so I'm going to flip it over. Factoring this first one, x minus 5, x plus 1, times 1 from when I flip, over x plus 5. This factored I've already done. It's x plus 5, x plus 1. So for sure I see canceling here. And you might think, oh, those are just opposites, it's a negative 1. But this whole thing is not the opposite of this whole thing. Only the 5s are opposite. This would also have to be a negative if I wanted to cancel and put a negative 1. But I can't. So it has to stay the same. It has to stay x minus 5 over x plus 5 squared. I'm going to shrink those down. And we know, of course, from the beginning that x cannot be negative 5 or negative 1. I still see the negative 5 here. I don't see the negative 1, but I can't lose it. So those are our examples for part C.